All right, so in the last video, we went down a bit of a necessary rabbit hole, is how I like to describe it. Um, the way that we journey through these videos is more how my brain thinks. So there are going to be some rabbit holes, but it's generally useful. It's because it's needed. You have to know these things, so we'll talk about them as we go. I have a very loose script and plan that I'm following here. All right, what we're going to do, we need to finish gathering up our example of the post request we have. For example, we were talking about the form encoded. There are other pieces. For example, if you want to go upload a file, you may have this multi-part slash form data. So if I'm doing a binary file upload, it's probably going to be using this. And this has its own separate structure. And as we write code to parse this, we will probably circle back and take a more detailed look at this. For example, let's see, the Mozilla Developer Network, the web docs here. Yeah, so for example, let's pretend on some file upload form, we have said example.txt. Here's what that looks like if it comes into the server is, we might have a file called example.txt, and then the contents of it is value2, whatever. Cool. So we'll get to that when we need to deal with it. As it is, let's go ahead and copy this so we can have a reference of it. And copy this. Make a divider. And so I have form data and then text plain. All right. Gonna make another divider here and boom. Okay. So the goal that I have is that we have these examples of different types of requests that can come in. While we're at it, let's do. Forgive me. We're going to go back to the get and see. Do they have an example of? No, they don't. All right. It's a little bit of a rabbit hole, but it's worth it so that I don't get yelled at later on in the comments of well, what about this type of GET request? Or what about URL parameters, which some of you may be aware of, some query parameters here. So let's gather an example of, if we can find it, query parameters. Nope, we're gonna have to make it up on our own. Okay, that's fine. Part of the journey. We're gonna come here and we're gonna say, number one, let's make a divider for ourselves. Divider again, and make a clone here. But what we're going to do is, say it's like, let's say we have an endpoint called find, and we're going to say, let's say keyword equals yellow. I don't know. Well, we won't have an example of where we need to be able to parse out the URL parameters here. So, cool. So we got some examples of things that we need to be parsing out, and let's go ahead and create a project. So let's do this here. Since we're using Rust, the way that you initialize a project in Rust is you have an application called Cargo. Cargo is sort of like your node, your npm build, or your go build, go run, whatever. Any of the newer languages generally have sort of a project manager builder tool, and for Rust that's called Cargo. So we're going to say cargo init http parser. Cool. So we've created that. And now what we can do here is open up our folder for HTTP parser. And go ahead and save this inside of our HTTP parser as um, target requests. Oh, okay, and it'll be, I'm going to access it here. All right, cool. Let's make this bigger. If you're editing things, I use VS Code because it's easy. There are people who, they like various other more full-bodied IDEs or integrated development environments. Some people use just plain text editors like Notepad or Notepad++. I like Visual Studio Code because it's fast to get started. If you have memory on your machine, most of us have enough memory on our machines, you'll be fine. If you're in a more resource-constrained environment, it may eat up all of your RAM. So work with what you got. All right. Anyway, moving on. When you're creating an initial binary instead of Rust, with your default project, it's expecting there to be a file called main.rs. And if you want to then go on and create any additional modules, you're going to do what I'm about to show you, which is, number one, we're going to type lib.rs. So this is where we can connect in any additional modules that we want to potentially be globally available throughout our project. Right now, we only have main. We don't need to connect to main end. That would, number one, I don't think you can do it. And if you did, it'd be cyclical and probably blow up. But what we're going to do is say, let's go, what should we call this? Let's go, let's just say http.rs. All right, sweet. Now, my reason for doing this is that, again, going back to the whole idea of testing, we want things to be modular. We could well, to a certain size extent, we could very easily put everything inside of a single main.rs file. Just it starts to get a little bit unmanageable past a few hundred lines, and it's generally not good project organization. When you are able to separate your different, let's call it groups of related functions or modules into different files or different parts of your project, it generally makes it easier to test. It makes it easier to reason about. It makes it easier to navigate when you want to say, hey, I want to go later on, if we're building up an entire web framework, which we may, you want to know, okay, where is my HTTP parser code? Because I got some requests and the whole thing blew up. Where do I go to fix it? And we will know that it's in this http.rs. Ideally, if you have your main function, if it's in C or Python or whatever, you're going to aim for having the smallest main function possible. So you can just say most applications generally have a big loop that you go in as you're executing your code. You want your main to show, in general, what the high level functions are of your application loop. You don't necessarily want to be writing all of your business logic, the fine details of your business logic, inside of your main function, or necessarily even inside of your main module. You want this to be the highest level glue, the string on top that holds the package together. You don't want it to be the package itself. As an initial thing, we have our hello world, but we want to be able to access whatever we're about to do over here in this HTTP module that we have created. And the way we do that is we go pub mod HTTP. What these two keywords are doing is pub makes it so that our code inside of this module here is potentially globally accessible. So other pieces of the application can look at it. It has the other benefit for us as we are writing code that it lets the analyzer, the compiler system, and basically the language server, the thing which is constantly checking over our shoulder and telling us whether or not we're doing stuff correctly. By adding in this line, it makes it so that this analyzer knows, hey, we are actually trying to use this file. Check it, make sure we're not blowing anything up. So if you've never written Rust, this is just one of the common patterns that you follow. It's a little bit odd if you haven't done it before. Like a lot of the time you'll have lib, you might have some global constants that you define in here that you use everywhere. And this is just sort of becoming the nexus through which you connect everything back into your main. So cool. So all that being said, what we're going to do is we're going to create a function here in this module called test HTTP. Since we're making an HTTP parser, we're going to say pub function test HTTP. We're not going to give it any parameters, and we're just going to not return anything for the moment. If this fails, then we're going to actually make it crash. Cool, so we have our initial test HTTP function. We're going to go back to our main, and we're going to link it in here. Immediately, the analyzer is saying, I don't know what you're doing. So we can come here, we can, not comment it out, but we want to check. And it says, okay, you must be wanting to do this. So it's wanting to import this package. So the name of our project is HTTP parser. You want to use the submodule HTTP and this function test HTTP. Cool. So now we save. Everybody's happy, honky dory. And for the sake of testing, we're going to go print line, say inside of test HTTP. All right, all is well, no red, so we're not dead. And we're going to go terminal, start a new terminal here, and say cargo run, cargo run release. This release means that we're going to be trying to make optimized builds. If you have a very large project, this can take a while sometimes. There's a lot of nuance as to what causes it to go slow. But for our purposes here, we're just going to use it since we're not pulling in a lot of external things. And most of what we're using is a standard library, and it's already been pre-compiled for us. So we can go this, it'll do a little bit, and there we go, half a second, and we're building. And we see, number one, we go inside of our function, we come back, and then we print hello world. And the application at that point ends. So this is putting us into the position where I believe in the next video, we will actually start writing our parsing code. All right, thanks, and we'll see you next time.